Hello dear students, here I am going to take some properties of inverse trigonometric functions. See, I have written two types of property. There are lot many types of properties. Two types of properties I have written. Sine inverse 1 upon x is equal to cosec inverse x. Very important. Provided this x is greater than 1 and less than equal to minus 1. Cos inverse 1 upon x is equal to sec inverse x. Again the same limit, x greater than equal to 1 and less than equal to minus 1. Tan inverse minus x is equal to tan inverse 1 upon x is equal to cot inverse x, x greater than 0. I will prove the first one and another you will do. See, look here, I am going to prove this. You will see it. I will write let sine inverse 1 upon x is equal to theta. This will give me sine theta is equal to 1 upon x, and I can write cosec theta is equal to x. Then theta is equal to cosec inverse x. This lies within the range. The range is already given. Now theta is this, theta is this. Ultimately, sine inverse 1 upon x is equal to cosec inverse x. This is important. Similarly, you will do these two properties also. Now, if I come to the second type, see second type properties again very important. Second type properties, sine inverse minus x is equal to minus sine inverse x. This we will use even in this differentiation. Many times we use this kind of properties in integrations and other places also. So many places inverse trigonometry is very important. So understand this and always remember all these. Sine inverse minus x is minus sine inverse x. See how important is this. Cos inverse minus x is pi minus cos inverse x. Limit provided all these limits. X will be within the limits in each and every property. Tan inverse minus x is minus tan inverse x. Cot inverse minus x pi minus. See look here. Cos cot sec बिल्कुल एक सा बिहेवियर रहता है. अभी मैंने इससे पहले भी आपसे बात करी थी. साइन टेन एंड कोसेक. साइन टेन और कोसेक का बिहेवियर एक सा रहता है. आई विल प्रूव दीज टू. मैं ये दोनों को प्रूव कर सकती हूँ. यू विल लुक एट दिस. Sin inverse minus x is equal to, let us write theta. This will give me minus x is equal to sin theta and x is equal to minus sin theta. Since this theta lies from minus pi half to pi half, so here I will write sin of minus theta. Reason, minus theta is any angle of fourth quadrant. Then this will give me sin inverse x is equal to minus theta. Theta is equal to minus sin inverse x. Minus sin theta will be equal to minus sin. This minus I am going to just remove. Minus sin inverse x. Now theta is this. Theta is this. Ultimately, sin inverse minus x is equal to minus sin inverse x. Similarly, if I go for cos function, cos inverse minus x, suppose I write theta. This will give me minus x is equal to cos theta and x is equal to minus cos theta. See look here. Here theta lies from 0 to pi. Then this negative angle will be of second quadrant. I will write pi minus theta. Now use invertible function. Cos inverse x is pi minus theta. Then theta will be equal to pi minus cos inverse x. Now what is theta? I have theta is cos inverse minus x, and now I got this. Similarly, you will do other. Now I will write other type of two more properties which are also very important. Now see, look here, type 3 properties. Sin inverse sin x is x, provided this x should be from minus 1 to 1, and cos inverse x is equal to again x. The limit is within its limit. Then another similar kind of properties may be sin inverse sin theta is equal to theta. This is also important, provided this theta will be from minus pi half to pi half. cos inverse cos theta is equal to theta, tan inverse tan theta is equal to theta, provided this theta should be within the limit. So this is about third type property. Fourth type property I have written, very important again, cos inverse x plus sin inverse x is equal to pi half. Sin inverse x plus cos inverse x is equal to pi half. I am going to prove this. See, look here. Let me write. Let cos inverse x is equal to theta. This will give me x is equal to cos theta, and I can write sin pi half minus theta. What is the reason? This theta for sin and cos will coincide in first quadrant. All right, because cos इनवर्स का जो cos इनवर्स का जो रेंज होता है वो होता है 0 to पाई, और साइन इनवर्स का रेंज होता है माइनस पाई हाफ टू पाई हाफ. देन जो दोनों का होगा cos इनवर्स x और sin इनवर्स x दोनों का होगा 0 to पाई हाफ, ये कोइंसाइड करेगा, इंटरसेक्शन होगा इन दोनों का, इंटरसेक्शन इन दोनों में जाएगा. देन cos थीटा को आई कैन राइट sin पाई हाफ माइनस थीटा. अब इसमें अगर इन्वर्टिबल डेफिनेशन आप यूज करते हैं तो दिस विल बिकम sin इनवर्स x इज इक्वल टू पाई हाफ माइनस थीटा. नाउ शिफ्ट दिस, ट्रांसपोज कर दीजिएगा इस थीटा को, दिस विल बिकम पाई हाफ sin इनवर्स x प्लस cos इनवर्स x इज इक्वल टू pi half. This is the proof. Now you can do other two properties of the same kind. Let us move for the fourth kind property. Fourth type property is tan inverse. Very important. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, provided this xy should be less than 1. Otherwise the formula will be another. Let us prove this. If I write let tan inverse x is equal to a, tan inverse y is equal to b, this will give me tan a is equal to x and tan b is equal to y. Now see, if I write a, tan of a plus b is equal to what? Tan a plus tan b upon 1 minus tan a tan b. See, look here, in place of this I can write tan b का प्लेस पे y और tan a का प्लेस पे x हम अगर लिखते हैं तो this will give me a plus b is equal to tan inverse x plus y upon 1 minus x into y. Now in place of a and b write down tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Other these two exactly same manner you can do. Now these are the very important properties of inverse trigonometry. You will do the problems and we will use all these formula or these properties while doing integrations and differentiations. Okay.